Okay, FN1, here is chapter 14 of Professional Cooking 9th edition. This is our second chapter on starches, and we're going to cover basically most of the other starches that we use in North America for meals. The chapter is legumes, grains, pasta, and other starches. We're going to go ahead and skip the legumes part. Legumes are basically beans and some peas. And we really don't have the time in this class to get into every possible thing we could talk about, so we're skipping over the beans and we're moving directly into grain. So what is a grain? Grain is essentially a seed, and it comes from a variety of grasses, and the seeds have four parts. The husk, which is an inedible fibrous outer layer. Inedible meaning you can't eat it, or you shouldn't eat it. It won't chew up, it won't have good texture, it won't cook and soften. So typically the husk is removed during processing before you get to the edible part. The endosperm is the bulk of the grain. That is mostly starch. The bran is a tough but edible layer covering the endosperm. And then the germ is a tiny embryo. That is essentially the new plant that the seed will turn into if it is allowed to grow. So here we have a little GIF showing the processing of a grain. The A coming up right now shows the rice with chaff. The chaff is essentially the hull that gets removed from the grain as it's processed. The B right here is the brown rice. So that brown rice contains the endosperm, the germ, as well as the bran. Those three things make up that whole grain. And then the C is the rice with the germ. Typically, the process of taking the bran off will also remove that germ. And so what you end up with in A is this. That is just white rice. And this, of course, goes for any grain. Most grains have this similar structure. Some are structured slightly different, but most of them have this structure. And oftentimes we process them down to the point where it's just that starchy endosperm. That germ, which is the embryonic plant, remember, is not just starch. There's also protein and fat in that germ. And that becomes very important when we talk about storing whole grains because of the fat primarily. And then that bran, which is another part of the edible part of the whole grain, that's got some starch in it, but it also has fiber, but that fiber does soften up as we cook it and makes it so we can eat it. So if you see a product labeled as whole grain, it is the endosperm, the bran, and the germ. If you take that whole grain and polish or mill it to remove the bran and the germ, then you end up with just the endosperm. And in the case of rice, that would be white rice, but there are other polished grains that are only the endosperm. Now, many of these processed grains will be enriched. And enriched essentially means that you've lost some nutrients in the processing of this product. And so you're going to add some of those nutrients back. And in the case of rice, very commonly white rice is sold as enriched rice. The nutrients they're adding back are B vitamins and iron. So you're going to see the thiamine, the folic acid, things like that added back. And it's added as a powder that coats the outside of the rice. So when it comes to different types of grains, we're going to talk about rice first. Remember, regular white rice, that's probably the most common way rice is eaten in just the endosperm form. That's had that bran coating and the germ removed. It produces a white, lighter textured product that a lot of people prefer over brown rice. I'm a big fan of brown rice because it's nutritious, because it also has the fiber that is not added back to the white rice. And I actually like the flavor of brown rice, but it's a different product. You should really consider them as different products. White rice is more bland in flavor, and people tend to like that. Brown rice, that bran, has a richer, deeper, even nuttier flavor that some people aren't down with. Some people think it tastes kind of like dirt. I'm a fan of brown rice. Rice comes in a variety of shapes. Different species of rice will look differently. And so we will classify those as either short and medium grain rice or long grain rice. And when you look at the actual raw rice, the short grain isn't significantly shorter than long grain, but it's short compared to its girth. Short grain and medium grain tend to be fatter grains, whereas long grain rice tends to be long and slender. When you cook them, the short grain and medium grain stay short and kind of fat, whereas the long grain rice tends to expand lengthwise and get even longer. So cooked, it definitely is a longer rice. Short grain and medium grain rice have a type of starch that causes them to be more sticky when they're cooked, whereas long grain rice, the starches allow them to be fluffy and stay separate. So if you want a rice that sticks together, choose a short grain or medium grain rice. If you want a rice that's loose and flaky and fluffy, you'd want to choose a long grain rice. Parboiled rice, sometimes called converted rice, is a rice that starts as a whole grain, and then it is soaked and then partially cooked under steam pressure. And that pressured steam actually forces some of the vitamin and mineral content out of the bran into the endosperm of the rice. After it's partially cooked, it is dried out and then processed to remove the bran and the germ, ending up with just the endosperm, but it's an endosperm with a higher vitamin and mineral content because it got pushed in from the bran. It also tends to color the endosperm a yellowish color from some of the colors that are found in the bran. It also has an effect on the starch. It gelatinizes the starch, and then as you cool it, the starch goes into what's called retrograde starch, and it gives it a different texture, which means that when the rice is cooked, it tends to have a chewy texture, which isn't like most rice. So I personally am not a fan of parboiled rice, but it does hold well for long periods of time because it doesn't turn mushy. It stays kind of that firm but chewy texture. It's also very easy to cook because it's hard to overcook it, or harder to overcook it. And for that reason, parboiled is probably the most widely used rice in food service. You're going to see schools using it, hospitals using it, prisons using it. Pretty much any large institutional facility is going to be using parboiled rice because of the ease in cooking and the length of holding time that it gives you. If you're trying to make a very delicate, fine rice, then parboiled is probably not the type of rice that you want to use. There's also a product out there called instant rice. Instant rice has been fully cooked and then dried out. It can be prepared quickly, but it tends to produce a very poor product. It tends to be very mushy. You lose a lot of the shape. I would avoid instant rice. Rice is relatively easy to cook from raw. I would avoid instant rice in pretty much any form. Brown rice is that rice that has the bran layer left on, and that typically means it still has the germ on there. And keep that in mind again when we talk about storage of grains. Because brown rice has that fiber in the bran, it takes roughly twice as long to cook it as it does white rice. Not only are you hydrating the starchy endosperm and gelatinizing the starch in that endosperm, but you need to break down some of that fiber in the bran in order to make it edible, and that's what takes so long. Keep in mind, Brown rice is a description of the processing of the rice. We're going to talk about some varieties of rice here in a second, and any one of those varieties could be sold as either the white form or the brown form. It just depends on how much processing it's gone through. So you can get white long grain rice and brown long grain rice. You can get white short grain rice and brown short grain rice, etc. So as we go through these next varieties, just keep that in mind. Most of them are sold in the white form, but if you look, you can find the brown form. So speaking of varieties of rice, a lovely rice from Italy is arborio rice, and that's one of several varieties. So this is a very good example of these types of rices from Italy. Another one that is really nice is called a riso fino, which essentially just means fine rice. But arborio is a medium. I know it says short grain on your list here, but really it's a medium grain rice, and it's used in making a very specific dish called risotto. And we're going to talk about risotto when we get into the ways of cooking grains, so we'll hold off on that for a second. But this is an Italian rice that has the sticky starches in it. Basmati rice is a extra long grain rice that's used in India and some of the surrounding countries. It's also now you can find some hybrids of it and varieties of it grown in various parts of the world, even in the United States. There's some, I believe it's called Texmati, and it was bred in Texas, and they're growing that there, and it's a great rice. Basmati is what's referred to as a fragrant rice. It has a floral-like flavor, and it's very delicate, and it's one of these rices that maybe doubles in length when it's cooked, and so that's why it's called extra long grain rice. And a lot of chefs will say basmati is their favorite rice because it's this very delicate, fine rice that has a wonderful light floral flavor and aroma. Jasmine rice is actually my favorite rice. This is a long grain white rice from Thailand and other parts of Southeast Asia. This is similar to basmati rice in that it has a floral scent. It has the lightness to it, but it's not nearly as long or as delicate. It's more in line with a standard long grain rice as far as the size and the strength of the cooked grain. But it does have a really lovely, lovely flavor. If you're a fan of rice pudding, and I know everybody isn't, some people don't like it, but if you do like it, make rice pudding with jasmine rice, and you will thank me later. Wahini rice is a red rice. This one is very often sold in brown form, but because of the color of the brand, it actually looks more red, and then the endosperm has this kind of an earthy red color, and then it has a kind of an earthy, rich flavor. Really, really great rice. Wild pecan rice is not actually a wild rice. It is cultivated in Louisiana. If you buy rice that says wild rice, that's not wild pecan rice. That's a different grain altogether. If it says wild pecan rice, it's not wild, it's cultivated. And I know that might be confusing, but that's just marketing terms, I guess. Glutinous rice is oftentimes called sticky rice or sweet rice. It's sweet just because of the natural starches that are in this rice. This is a short grain rice that's very sticky and chewy when cooked, and this is very commonly used in let's say sushi rice. That you would use a glutinous rice to make sushi. A good example of a glutinous rice would be calrose. Calrose is a very easily obtained common short grain sticky rice that you could turn into sushi rice by cooking it and adding the seasonings that make it sushi rice. So we're going to follow this up with some pictures of rice. I think the pictures in the book are going to come across clear, but maybe you're still getting the book. Hopefully not. This is week 3. But we've got basmati rice, glutinous rice, plain long grain rice across the top, Japanese short grain rice, jasmine rice, and arborio rice across the bottom. It would be really cool if they had these with the cooked pictures as well, but they don't. And here we have wild rice at the top left. True wild rice is wild but not rice. And then we have wahine rice in the middle, and you can see that's a very red color. And then on the far right, we have the wild pecan rice from Louisiana. So that is cultivated wild rice, which that's an oxymoron, right? Cultivated and wild. It is a cultivated rice, but it's called wild. On the bottom, we have a parboiled or converted rice, and you can see kind of the golden color. It's almost the same color as the brown rice, and that's because some of the color from the bran was pushed into the endosperm. And of course, the brown long grain rice on the bottom right. Moving away from rice, we have some other grains, and number one, corn. Corn is a grain, and very often in this part of the world, we will eat corn as a vegetable, and we've bred corn to be high in sugar and low in starch so that it can be eaten as a sweet vegetable, but it is a grain. The structure of corn is a little different. If you eat corn, you can the outside layer, the tougher layer, that's the bran. The inside starchy layer, that's the endosperm, and sometimes you'll see like a little pip in the bottom of the corn. That's actually the germ. In this case, instead of a husk covering each grain, you have a husk that covers multiple grains in one ear. If we're going to use corn as a grain, it's a different variety of corn, and it's typically dried and ground into a meal or a flour. Meal is essentially just a coarse grind, and a flour which is finely ground. So you can have corn meal, which is going to be coarse, and you can have corn flour, which is going to be very fine and powdery. Typically, flour is going to be made from just the endosperm, and that's going to be referred to as a white flour. If I grind the whole grain, it's going to be whole grain flour, and it typically won't have as fine of texture as the white flour. Corn, depending on how it's processed and then ground, can be a variety of different products. We have a polenta, and polenta is essentially cornmeal. It's another name for cornmeal. Polenta oftentimes comes in a coarser grind than your standard cornmeal, and then it's the name also applies to a dish made with this coarse cornmeal, which is like a porridge or a mush made from cooking the polenta with water, salt, maybe adding some butter, and you can dress that up as much as you'd like. Hominy is corn that has been treated with lye, and that process is called nixtamalization, and it actually makes the corn healthier than standard corn. It releases some nutrients from being trapped in the corn, so now you can actually, your body can extract those from the corn that you eat, and it makes it healthier. The hominy in whole grain form is often referred to as pozole, and if you dry the hominy and then grind it up, that's where we get grits. So grits are very similar to polenta, but polenta is made with corn, and grits is made with hominy, which is treated corn. Of course, corn comes in a variety of colors. White and yellow are the two most common, but it also does come in a blue color, and I've seen some other colors out there as well. Red is one. And blue corn is derived from a very early variety of corn before it was turned into this more vegetably sweet type of corn. But it can be turned into blue polenta. It can be popped, etc. So that's corn. Moving on to wheat. Wheat has a very similar structure to the standard grain structure that we looked at the start. It's got the endosperm, the germ, the bran, and then the husk on each individual grain. Typically, wheat in this part of the world is usually stripped down to the endosperm and ground into flour, and that's where we eat most of the wheat. You can buy wheat germ by itself and wheat bran by itself, or you can buy whole flour, which has the germ and the bran ground up with the endosperm. You can buy bran flour, which is the bran separated from the endosperm. They're both ground up very finely and then mixed back together without the wheat germ there. Bran flour is just the bran and the endosperm. And these are used to make baked goods and added to other dishes for, we can use the starch for thickening and it adds flavor. So we use that as a ground grain. We do use some wheat in the form of the whole or coarsely chopped grain. Cracked wheat is a whole wheat grain that's been cut into smaller pieces. Wheat berries are the whole grain, minus the hull, of course, the HULL. And you can cook a wheat berry, and I've had wheat berry salads, and so it's the entire grain without it being cut up. Bulgur is a cracked wheat that's been partially cooked, and that comes in a variety of granule size, coarse, medium, and fine, and it's used in some cultures. A very popular salad from the Middle East is made with bulgur wheat, and that's tabbouleh. And that's oftentimes referred to as a description as a bulgur wheat and parsley salad. You can also harvest wheat green, meaning immature, and then dried out, and that's referred to as green wheat, and it has a different nutritional profile than fully mature wheat. So that's another product that's out there. And then finally, couscous. Couscous is not a grain, even though it resembles like a bulgur particle or a cracked wheat particle. It is not actually a grain in and of itself. It is made from wheat, but it is a pasta. It is made from the same type of dough that macaroni noodles and spaghetti noodles and lasagna noodles are made from, only the dough is made fairly dry and then it's rubbed together until you get little grains, little granular bits of pasta. Those are then allowed to dry and then they're cooked and you get this granular type pasta dish. But it's made from a flour, a semolina, which is a coarsely ground flour made from a durum wheat, which is very hard winter wheat with a lot of protein. We'll talk more about protein types when we get into our baking chapter. Wild rice, again, is not actually a rice. It is a seed of an unrelated grass. This is actually native to the northern United States and Canada. There are a bunch of other grains out there that have gained in popularity recently as people are looking for more interest and variety in their diet and potentially some health benefits from some of these. Farro is thought to be an ancestor of modern wheat. It's very wheat-like. Spelt is another grain that is, I'm sorry, farro and spelt are the same grain. It's just another name for it. Kamut is another grain that might be an ancient relative of wheat. Again, it's very similar to the farro. Buckwheat is technically, again, not necessarily grain. It's a seed of a plant that has broad shaped leaves versus the grass long thin leaves, but it's treated like a grain. We make pasta from buckwheat. We make something called, soba noodles are made from buckwheat. We make something called kasha, which is a toasted buckwheat cereal. Barley was super popular a couple decades ago. Now mostly you're just going to see it used in soups. I think barley is ready for a big comeback because it's a really healthy grain. I don't know if it just has a bad name or whatnot, but it's a grain like these others. Oats are fantastic nutritionally. Typically, we're going to eat oats in the rolled form, and to get a rolled oat, we're going to take that oat, which is very rice-like in shape. It's long and skinny. We're going to cut that up with big steel cutters, and that turns the oats into what's called steel-cut oats, sometimes called pinhead oats or Irish oats. And these steel-cut oats are then steamed for a little bit to soften them, and then flattened underneath big stainless steel rollers. And that's why they're called rolled oats. The rollers flatten these little bits of oats into flat, round oats. And depending on how much they're steamed in the first place, you can have standard oats, which require a fair amount of cooking because they're just barely steamed to get soft, or quick oats, which means they've been steamed quite a bit, they're mostly cooked, and then they're rolled flat and dried, or instant oats, where we've fully cooked that oat, we've squashed it flat into a little disc and dried it, and now really all that oat has to do is hydrate, and it's fully cooked. Amaranth is a tiny yellow-brown seed that has a really nice nutty flavor. Millet is a tiny bright yellow round grain. It's been a very important food source in Africa and Asia. Typically you're not going to find millet in North America being served as a grain. Where you will see it is in birdseed. If you look at birdseed, those tiny little yellow balls, that's millet. But it's perfectly edible for humans. You just got to cook it right and eat it. Quinoa is a very important grain that's native to the South American Andes. Quinoa got big maybe 15 years ago. It was one of the first superfoods, and I know it's a big buzzword, talk about foods as being superfoods, but quinoa is special because when it comes to grain products, it has a relatively complete protein. And I don't want to get too much into protein and completeness and quality here. We'll talk about that more in the nutrition chapter, which is chapter 5. But just consider that quinoa by itself will give a better protein than these other grains by themselves. So quinoa became an important food for people that were concerned about their protein intake. And again, we'll talk more about protein and complete proteins and quality proteins when we talk about nutrition in general. So here are some pictures. Again, I think the pictures in your book might be easier to recognize what's going on in there. We've got Egyptian green wheat on the top left and wheat berries. You can see they look a little bit like a fat rice, right? Grains are grains. Couscous on the bottom left. Again, it looks like a grain, but it's just a tiny little ball of pasta. Kasha, and which is that toasted buckwheat that can be cooked, usually like a warm cereal, or it can be partly cooked and dried and then eaten in milk like a cereal. And then farro on the bottom right, which is that possibly ancient relative to wheat. And then we have quinoa on the top left. Quinoa is got a different shape than most grains. It's more flying saucer shaped, a little disc, and the bran actually wraps around it in a band with a D. Then we've got triticale in the middle, pearl barley top left. We've got blue cornmeal bottom left, so that's a blue corn that's been dried and ground up, ready to make some blue polenta or blue tortillas, something like that. Pozole in the center, middle, and then bulgur wheat on the bottom. When it comes to the storage and handling of grains, because they're dry, are not a TCS food. They don't need to be refrigerated, but you do want to keep them in dark, dry place. They should be in a tightly sealed container. That helps to keep out moisture and insects. Keep in mind, whole grains, or grains in general, it's almost impossible to make sure all insect eggs are off of them after processing. So even a tightly covered container may develop insects given enough time. So the idea here is you want to purchase grains and then use them before they start to grow the insects inside of there. And if you consume an insect egg, it's not going to hurt you. It's just a little extra protein. But you don't want to, of course, allow the insects to start to grow in there. Whole grains are more perishable than polished grains and our white grains because of that fat content in the germ. It is specifically the fat in the germ, because fat can become rancid. I'm not sure, I don't think we talked about rancidity before. We did talk about the smoke point of fat, where the fat breaks down and those small little pieces of fat don't taste good and aren't good for you. Well, fat can spontaneously break down, and that's hastened by things like light, heat, oxygen, moisture. All of these things can encourage the fat itself to break down, and that process is called rancidity. The fat in whole grains, in the germ, can become rancid, and once it is, there's nothing you can do but throw it away. You don't want to eat it. It tastes horrible, may not be good for you. You just want to get rid of that. Whole grains, because they're not processed as much as the white rice or the white grains, you do want to make sure you're looking closely at them for foreign matter like tiny stones or bits of soil. And you know, it doesn't hurt to be careful with all grains. I found little chunks of dirt and rocks in my white rice as well. Because it is an agricultural product, there's always a chance for some of that to get carried through the processing. So you want to look through your grains as you work with them to make sure you're getting out any foreign physical contaminants. Rice, which is our most commonly cooked grain, should be rinsed in cold water before boiling or steaming. As the rice sits in a bag or whatever package it's in, it's rubbing against other grains, and that is milling off some free starch, and that starch is coating the rice. When we put that rice in water, that free starch is going to mix with the water and cook up into essentially like a glue. And as we boil the rice down, the water is going into the rice and evaporating away. That glue matrix is going to solidify around the rice and making it gluey and not pleasant. So to make a better textured rice, we will rinse our rice. We'll add water to the rice, swirl it around, pour off that water, and it's going to come off looking like milk. And then we'll rinse it again, swish it around. I like to rinse at least 3 times, and when you pour off the last addition of water, it should be coming off relatively clear. It should look like just water. My sister-in-law, I remember watching her teach my mom how to cook rice the Japanese way. She was born and raised, and she's of Japanese descent, and she was teaching her how her mom taught her to cook rice, and in that tradition, they washed the rice 7 times to make sure all the starch was gone. And that produces a very fine rice. Now you might be thinking about the enriching process. If I take a white rice that's been enriched with nutrients, B vitamins and iron, sprayed on as then dried as a powder, if I rinse the rice of the starch, isn't going to also rinse off those vitamins? Absolutely it is, and that's unfortunate. If you are consuming a diet where you are concerned about the lack of nutrients, B vitamin, the iron specifically, don't rinse your rice. And if you're, many people in developing countries, they still need that enrichment to have the nutrition that they need. If you're eating a good and varied diet in North America, you are not likely deficient in those B vitamins and iron, and so washing your rice is not going to cause you to go deficient, and you end up with better rice. So culinarily, we're going to rinse our rice before we cook it. The exception here is if we're going to cook the rice by the pilaf method or the risotto method, and we'll talk about why we wouldn't rinse that coming up here in a second. So talking about cooking processes, the number one way of cooking grains in general is by simmering. In this case, you need to measure the amount of liquid exactly. The problem is that the amount of liquid needed depends on what type of grain, how old the grain is, how much moisture is left in it or is in it from sitting around in humid environments, If your cover is looser or tighter, that will change how much water is able to evaporate away. And of course, if you want a wetter product or a drier product. So it requires some trial and error to get the exact amount of moisture that you need to cook the right amount of rice. I can't say here, I cook rice and I use this much water for this much rice, you do the same, and expect that you're going to come up with an identical product. You need to use your equipment, your stove, your pot, your lid, your rice that you're going to cook. You're going to cook it to the desired quantity you want, and so it's going to take some testing to know exactly how much water. Now, we of course have guidelines. Generally speaking, we're going to use twice as much liquid as we use rice. So for 1 cup of rice, we would use 2 cups of water or some other water-based liquid. But then that's a guideline, okay? Because we will adjust that as needed. Different rices use different amounts. Basmati is going to take maybe 1.5 cups of water to 1 cup of basmati, etc. In the simmering method, we are going to add the grain to the water. We're going to bring it to a boil. We're going to simmer it, drop the heat down so that it simmers. With a cover on, we're going to simmer it on low temperature for 20 minutes. We're going to let it sit for 10 minutes off the heat, and then we're going to open up the cover and fluff it and check it for doneness. There's a few things you can do if rice is under or overcooked. If it's overcooked a little bit, you can spread it out on a sheet tray and put it in a warm spot, and it will evaporate off some of its excess moisture and firm up a little bit so it's not too mushy. If it's overcooked a lot, it's going to end up with porridge. If you've undercooked it a little bit, you can boil some water, put it into the pot of rice over low heat, cover it, let it steam for an additional 5 minutes. Don't add too much water or you're just going to end up with mushy rice, but that can finish hydrating those rice grains and get you with to a cooked rice spot. Another method that we can use is called the pasta method, and we call it that because we're cooking the rice like a pasta. We're going to add the grains to a large quantity of water. We're going to allow the grains to fully cook, and then we are going to drain the water or strain out the grains, and now we have a fully cooked product, and that's left behind. Any of that excess starch will be left behind in the cooking water, and so we get a nice looser rice that's going to flake apart easily. We don't have to measure as exactly with the water. So this, again, uses more water, so it's a little less friendly to the environment, but it can produce a really nice rice product. When we simmer a meal or a cereal, remember a meal is a ground up coarse grind. Large particles like oats can be stirred into boiling water and don't lump up. If you stir like cornmeal into boiling water, it's going to clump up. And so I'm going to actually disagree with your book right here, where it says granular meals like cornmeal should be stirred slowly into boiling water to prevent lumping. I'm going to say you're either going to whisk it into boiling water, so boil the water, pour the cornmeal in, and whisk it while it pours in to break up any lumps, or you can actually whisk in the cornmeal to just under boiling water and then bring it to a boil. The only danger of that second method is scorching, so you need to make sure you're stirring very regularly, because once this cornmeal starts to cook up, it becomes very thick and it's not going to move around with convection anymore, and you need to stir it. Okay, the pilaf method and the risotto method are very similar in that we start with a grain and we toast it in fat. And that is the key to the pilaf method. Let's talk about rice pilaf here. Rice pilaf is rice that has been coated in fat, and that's the key, is each grain of rice is coated in fat, and then a liquid is added, and that fat essentially lubricates the grains so that they stay separate, they don't stick together. The fat also adds some flavor and some richness to the dish, but the point of rice pilaf is a loose, flaky rice, and so we're going to coat the grains in fat to keep them loose. Now, I mentioned before, sometimes we don't rinse our rice. If we're going to coat the rice in fat, we don't necessarily need to rinse the rice. If you do rinse the rice and then you want to use it for pilaf method, it's best to have that rice re-dry off so that it's fully dry before you add it to the fat. Now, that being said, what makes it pilaf method is that you've coated the rice in fat. But if I'm going to warm up some fat, I'm going to take advantage of that fat and I'm going to add some aromatic vegetables to that. I'm going to add some onions at the very least, maybe some garlic, maybe some celery and carrots, something to give some nice flavor in there. I'm going to choose a flavorful fat. Butter has a lot of flavor. We could coat our grains with butter. You could do olive oil if you're looking to stay vegan. You don't want to use animal products in there. That's fine. Olive oil works fine. You can use a neutral fat like canola that has a very neutral flavor. Any fat works here. If I'm going to serve this rice pilaf with a piece of chicken, why not use chicken fat, right? I've got chicken fat sitting in my fridge right now. Maybe melt some chicken fat and coat my rice in chicken fat, and now my rice will take on a chickeny flavor because of the fat. In addition to coating the grains in fat, I'm also going to take the opportunity to toast those grains. And that toasting allows it to take on a nice nutty flavor. And you'll know it's toasting because once the grains are coated with fat, they'll look very translucent. And as they toast, they'll take on a white opaque color, and you'll start to smell a toastiness coming from them. They don't necessarily turn brown. You're not going for full-on dextrinization here. If you're browning it, you're probably burning things as well. So just get them to opaque whiteness and then add your liquid. Speaking of liquid, in your lab this week, you're going to use water, but you can use any water-based liquid that you want. Very commonly would be some sort of a broth or stock. So vegetable broth, chicken stock, something like that. You're just adding more flavor on top of these other flavors that you build. Past that, it's just like simmering. You coat the grain in fat, you add the liquid, you bring it to a boil, you drop it to a simmer, you cover it with a lid, and you allow it to simmer for 20 minutes. Very commonly, pilaf is moved to an oven, and that's because that oven can deliver nice even heat, whereas on the stovetop it's just the bottom burner. And remember, freeing up the stovetop is always a good idea. So in that case, you'd bring it to a boil on the stovetop, put a lid on the pot, and then put it in a 350-degree oven and let that sit in the oven for 20 minutes. Then pull out the pot. It's going to be hot, so be careful. Pull out the pot and let it sit for 10 minutes with the cover on. Then you could open up the cover, fluff up your rice, and there's your rice pilaf. Rice pilaf can have all sorts of things added to it. Nuts. I like pine nuts in rice pilaf. You can have pasta. I know some people make pilaf with fideo or angel hair pasta broken up in there. My favorite pilaf has the fideo and the some Zante currants in there. It gives a little pop of sweetness. Wonderful pilaf. Okay, moving on to the risotto method. The start of the process is the same. You're going to melt some fat. You're going to toast some rice. You've probably, before you toasted the rice, added some aromatics to get some nice flavor in there. And then here's where the process diverges. Instead of adding all the liquid and bringing it to a boil, you're going to add some of the liquid, and you're going to stir that rice until the liquid's absorbed, and then you're going to add more of the liquid, and you're going to continue to stir that on the stovetop. This stirring action encourages starch to leave the grain and go into the liquid, and ultimately, when you're done with the risotto method, you should have fully cooked but still biteable rice, right? Al dente. Should be able to bite that rice. And then the liquid and the starch that came out will form a sauce. So you end up with a cooked but saucy rice dish that's very often, not always, but very often enriched with cheese or butter or cream or some sort of dairy fat to add richness to that sauce. And this again is very costly done with a short grain rice, and arborio would be the typical rice because this is an Italian dish. Now we're going to move over to pasta. Pasta is of course made from grains, very commonly made from wheat flour, but not always. Typically we're going to have water added to the wheat flour to make a pasta, and sometimes eggs added to the pasta. We're of course talking about Italian style pastas. There's a whole another category of pastas from Asia that we don't really have time to get into the huge world of Asian pastas here, and the variety is just almost endless there. So we're just going to talk primarily about Italian style pastas here. We have two basic kinds. The term macaroni is actually a term that relates to any dried pasta made from just flour and water. I don't know about you, but most people think of macaroni is a specific shape of macaroni called elbow macaroni. So when you make macaroni and cheese, you're using elbow macaroni. But spaghetti is a macaroni, lasagna noodles are a macaroni, fettuccine is a macaroni, fusilli, etc. Those are all macaronis. And they're made from a high-protein flour called durum wheat, and we take just the endosperm and we grind it into a flour called semolina. Semolina is a fairly coarsely ground flour. It's almost coarse enough to be called a meal, but it is a flour. But if you rub it in your hands, it's going to feel granular, not soft and powdery. Lower quality products are made from a softer flour that's ground finer, and it doesn't have the same kind of bite and texture as a good macaroni made from durum wheat. Egg pastas have egg solids in addition to the flour and water. Egg pastas are typically sold as a flat noodle. So if you want to make a fresh egg pasta, you can use flour, eggs, and sometimes water or oil. Typically, it just takes the flour and the eggs mixed together. You can use bread flour instead of all-purpose flour because the bread flour has a higher protein content and will make a firmer noodle. Other noodles, other flours can be used, like whole wheat flour, to make a fresh noodle, so you can get a whole wheat egg pasta. And sometimes we add either vegetable purees or powdered vegetables to add color and flavor to these fresh egg pastas. So you can make spinach pasta or red pepper pasta, etc. And of course, we have the other noodle products I was mentioning before, all sorts of varieties. We're not going to get too much into these. If you've never been to an Asian market like our market up on Cedar and Herndon, go check out their noodle aisles. It's so big it encompasses more than one. There are just so many varieties of noodles. We could probably teach a whole class on Asian noodles, but we're not gonna. Let's talk about cooking pasta. Pasta should be cooked al dente, or to the tooth. What does that mean? That means you have to bite through it. It's not so soft that it just mushes, but it shouldn't crunch. Somewhere in between mushy and crunchy is al dente. There's a lot of suggestions you might have heard for checking for al dente. I've heard people say throw it against the wall. If it sticks, it's done. All that proves is that you now have a dirty wall. The only real way to know what's going on inside of that noodle is to check out the inside of the noodle. So take out a piece and bite it, and you can feel if it's al dente. Pasta is typically best cooked and served immediately. If you need to cook large quantities, you can cook it ahead of time, shock it cold in ice water, get it out of the ice water, or it'll continue to absorb water, and let it dry, and then you can just pop that mostly cooked pasta in hot water for a minute to re-warm up. The yield on pasta is about 300%, meaning 1 pound of uncooked dry pasta will yield 3 pounds of cooked pasta. And I'll give you some of my personal experience here. If I'm cooking pasta to my version of al dente, what I want pasta to have the texture of, it's closer to 275, maybe even 250%, meaning 1 pound of pasta yields 2.5 pounds to 2.75 pounds. Understand, you could make a pound of pasta turn into 4 pounds just by cooking it longer and having it absorb more water. But you don't want that. You don't want that kind of texture. So the only way to really know how much your pasta is going to yield is to take a pound of pasta or some known quantity of pasta, cook it to the degree that you want it cooked, the texture you want it cooked, and then weigh it and find out how much it's turned into. And then you have an accurate yield for the pasta you want it, the way you want it. So because we're not in class, I took some pictures of what pasta should look like as it's cooking. And so this is various stages of spaghetti being cooked. And you can see on the left, this has been in the water for just maybe a minute. And if you'll notice right in the center, a big portion of white, that is the fully dry pasta, but there's a thin band of yellow, and that's the part of the noodle that's been hydrated. As you continue to cook that noodle, the water proceeds through the noodle towards the center, and you can see that white section getting smaller and smaller and smaller. And then in the final picture, hopefully you can see there is like a pinprick, a tiny little dot of dry pasta. That's when you pull it out. If you cook it till that dot disappears, by the time you get it sauced and get it on a plate and get it out to your customer, it's now overcooked. So you want to pull it out right when it has just the tiniest dot of dryish pasta in the middle, and then the moisture, which is greater on the outside than the inside, will equalize from the outside to the inside, and you'll end up with a nicely cooked noodle all the way across the all the way across the noodle, right? Wall to wall, it'll be a nice texture. So the next time you're cooking pasta, like say for instance this week when you're cooking your spaghetti carbonara lab, occasionally fish out a little piece. I like to just bite it off with my front teeth and then look at the pasta. Every minute during cooking, fish out a little piece of pasta without burning yourself, please, and bite into that pasta and look at the progression of the pasta cooking and recognize that on the far left with that little dot of dried pasta, that's what you're going for. Finally, a little discussion about dumplings. Dumplings are very similar to noodles. They tend to be a little more free form. We'll make a soft dough or a batter that is then portioned out somehow, simmered and steamed, and then served. What you're seeing right here is a pasta or a dumpling that's made by forcing a soft dough through a bunch of little holes into the boiling water, and then it is allowed to cook and then fished out as it starts to float, meaning it's expanded enough that the density is low enough that it can float, and it's done. And then they're shocking it cold in some water on the left, and then usually this is going to be heated up in a pan of brown butter for some delicious flavor. This type of noodle is called Spätzle, which is I believe German for sparrow or little bird, and because of the shape of the noodles, they look like little bird bodies. And that is our chapter on starches. Again, let me know if you have questions or if you thought anything was interesting or neat or cool, or you want more information on something. I'm hoping to have some fantastic labs for you to do at home that will illustrate some of the cooking processes we've talked about here. So again, let me know if you have questions, and I'll see you in Canvas.